Welcome back students to one more session of your CBSE sample paper 2018-19. Right, so we've already seen question number 1 to 6 with the internal choice. Now let's come back and solve question number 7. Right, so let's see the question first and start analyzing. Now what did they give us? In question 7 they said identify the reaction and the IUPAC and write the IUPAC name of the product form. Okay, so first important thing, whenever you see this acid, what is this acid? This is alpha, means an acid with alpha hydrogen. This is your alpha hydrogen, and when you see the alpha hydrogen with bromine and red phosphorus, immediately you have to get an idea. The reaction which is given to you is HVZ reaction. Okay, Volhard-Zelinsky reaction. So remember, this is the whole thing. This reaction, what should you remember? Here this is an alpha hydrogen, this is bromine red phosphorus. So HVZ reaction, that is the full form. Now let's write. So when you write this first product, let us write the product. In HVZ, the product form is, you see here, CH3. Okay, right? At this position, the alpha hydrogen, where I have written alpha hydrogen, there at that alpha hydrogen you have your bromo group. This bromo is introduced. Bromo and COOH is as usual. What is the name of this compound? This is 2-bromo propanoic acid. Propanoic acid. Okay, this is done. Now let us see the mechanism, or how is this formed in this particular compound. Now when I have to see the mechanism, I'm not completely giving the mechanism, I mean idea how is it this. So wherever there is alpha hydrogen, there is bromine formed. In the first step, let me take the bond line structure. This carbon, this is the point. I'm coming down. Okay, this is the carbon here. Then I'm taking this carbon here. So this carbon is the first carbon. This is the second carbon. This is the third carbon. I'm introducing COOH to this. Now done. Now here in the exam you can either take Br2 or red phosphorus, or it can be PBr3 also, not a problem. So in the first step, this OH group and your Br gets exchanged, they get replaced. So let us draw that thing, OH, and I said this is Br. What is this called? This is called acid bromide. Acid bromide. Now in the second step, again we have HBr and Br2. We are introducing Br2. Now what happens? Wherever there is alpha hydrogen, there is an alpha hydrogen. This is COOH. There is an alpha hydrogen, isn't it? This particular point, alpha hydrogen, this bromine breaks up and it comes and adds here. What do we get? We are going to get double bond O, Br, and this is Br. Now what is this called? This is called alpha bromo acyl bromide. Alpha bromo acyl bromide, right? Acyl bromide. Now alpha bromo acyl bromide, till we have not got the required product, isn't it? Further, what are we going to do? We are going to take this alpha bromo acyl bromide and allow it to undergo hydrolysis reaction. When you allow it to undergo hydrolysis, that is addition of water, this Br, it's like this, HB or HOH, this hydrogen and this bromine, okay, right, will get exchanged, and what do we get? We are going to get O, Br, and see here, careful, this whatever Br is there, this hydrogen and this Br comes out, and we get this OH here, right? So remember this. What is the name of this compound now? This is called, this is 1 carbon, this is 2 carbon, this is 2-bromo propanoic acid. 2-bromo propanoic acid. Okay, there. Now see here, this is 2-bromo propanoic acid, this is also 2-bromo propanoic acid. So this is what is the HVZ reaction. So important thing, whenever such question is given to you, you directly write the name of the reaction. I'll use this paper. You'll just write the name of the reaction. Here is reaction is HVZ reaction. Full form is Volhard-Zelinsky reaction. Okay. Next important thing, the IUPAC name, write it like this. This 2-bromo propanoic acid. Propanoic acid. That's it. This is the answer. So here for this particular thing, you will be getting half of mark. In the earlier one, for this reaction, you will get means this product written half mark here, and for the second one where you have written IUPAC, half mark here. Now let's see the next question. Next in part B, part here. Just important thing. This is called your benzoyl chloride, benzene ring with COCl, benzoyl chloride. Here you are dealing with, when you see lead and barium sulfate and hydrogen. Hydrogen is nothing but reduction, isn't it? What is the reduction in this hydrogen? What happens? This Cl and H comes out as HCl, and your hydrogen goes and adds here. So what product do I get? I get CHO. This is benzaldehyde. Benzaldehyde. Right? So what is the name of this reaction? The reaction name is, yes, it is right. The reaction is Rosenmund reduction. Rosenmund reduction reaction. And what is the name of the product? The IUPAC name they've asked me. So IUPAC name is nothing but benzaldehyde. Okay, right. So hope students, the reaction is clear. So both the things, one is HVZ reaction, one is Rosenmund reduction. Here you'll be getting half mark, and here you'll be getting half mark. Let's come back and see the next question. Yes, students. Now let's come back and do the OR question in 7th one. I told you there is an internal choice given this time. Now I am doing the OR question. Let's read. Write the structures and IUPAC names of the following of the cross aldol condensation products only for ethanol and propanol. Okay, I did one video for cross aldol condensation. So please go to the playlist. I am again telling you. They asked me to write cross aldol condensation with ethanol and propanol. I have done a lot of combinations in the cross aldol reaction. Please go to the playlist in my channel. There I have aldehydes. In that, aldehydes, ketones and carboxylic acid I have given under the playlist of aldehydes as cross aldol products or cross aldol condensation. Or you can go to YouTube and search for cross aldol condensation in the world of chemistry. You'll get it. Right. So what did I ask? Write the structures and IUPAC name this it. Done? Yes. So when I speak about ethanol and propanol, two cross aldol products, most important thing is we'll be getting 4 different products. They were asking us to write only for ethanol and IUPAC. Right, let's write. So first let us take ethanol. First one, ethanol is CH3CHO. Right, and the next one is propanol. This is your propanol. Correct? 3 carbons. Thus, most important thing is aldol condensation occurs in the presence of a base. Here I am not explaining the mechanism, but I have shown you in that video what are the products of cross aldol. Here I will be directly taking the reaction here. I will be writing the products, but please watch the video for clear understanding of cross aldol. Now it will be giving 4 different products to that. First one, just see, simple. I will give you a logic. Here 4 products. First product is but2-enol is one product. Second product is pent2-enol. Third product is 2-methyl but2-enol, just like the first one. Fourth one, same, 2-methyl pent2-enol. These are the 4 things. But2-enol, pent2-enol, 2-methyl but2-enol, 2-methyl pent2-enol. Now let's write the structures of all the 4. So remember this, for cross aldol start from but, then pent, then again 2-methyl but and 2-methyl pent. So when I have to draw the structures of this, what is the first product I said? Okay, let us write all the 4. I said it is but2-enol, but here I have not drawn this mechanism, but I am again repeating. Watch the video for the mechanism. So but2-enol, 1, 2, 3, 4. This is but. Okay, and but2-enol. So this is CH3. So in the second carbon I should have double bond. This is 2. Right? So this becomes how many? 1, 2, 3, 4. This becomes 3. So this is but2-enol. Next one, what is the product? I said it is pent2-enol. Again, pent 1, 2, 3, 4, 5 enol. So which position of this one is there? It is there in the second position. correct. So 22 in second position, double bond, so fill in the hydrogens. And after that, what is the next one? Just like this, it is 2-methyl but-2-enol, correct. Now write 2-methyl, first but 1 2 3 4, 2-methyl is second, done. So 2-methyl but-2-enol, so this is first carbon, this is second carbon, so fill in here. There is one more product here. What is the other product we got? The other product we got is 2-methyl pent-2-enol, correct. Yes, so write down again product 1 2 3 4 5. So second position, first position, second position is methyl group. Now again there is this is your 2-methyl pent-2-enol. So products are 4 products, right? So this is how you're going to write and list out. So the first product is, write this IUPAC name. Second product, write this, just like this. I've written now, write this. You'll be getting mark for this. I said this is all carries half mark each, so 2 marks is a question, right? Done. Now let's come back and see the 8th question, right? What did they give me? They've given me justify the role of tertiary butyl peroxide in the polymerization of ethene, they said. Okay, so basically when I speak about tertiary butyl peroxide, what is the role? There are 2 questions. They have just asked me what is the role and then in which one polymerization of ethene. So because this is a 2 marks question, if I just write the role also I will get, but to impress the examiner I'll be very particular about writing this. So first of all, you will write like this: role of tertiary butyl peroxide. So directly you will write the heading like that: role of tertiary butyl peroxide in which one? In polymerization of ethene. So you will write this and underline the whole thing: polymerization of ethene. And once you get, just underline this. What is the role? You have to get the mark directly, isn't it? So you will just write it acts as free radical generating catalyst. Okay, simple. Free radical generating, it will generate a free radical. I show you just now. Free radical generating. Okay, free radical generating initiator, or it is catalyst. Okay, free radical generating initiator, catalyst. This you write. Now to impress the examiner further, what will I do? I'm going to write the reaction mechanism. How will I write? Just see. So basically when I take tertiary butyl peroxide, it's going to follow 4, or if I say particularly 3 different steps. One is it will follow chain initiation reaction, it's going to follow chain propagation reaction, and it's going to follow chain termination reaction. That. So when it comes to chain initiation reaction, okay, the first important thing, the formula first in initiation, what did we say? We said 3 steps. Let us make into 3 columns. 1 column for initiation, 1 column for propagation, 1 for termination. So let us write the heading as initiation. You should be very fast in writing the exam. Right, initiation. After initiation, what? Next is chain propagation. After that, what is that? It is chain termination. I am not writing chain here. That. So in the first step, when I say chain initiation, so what is the thing we took? We took tertiary butyl peroxide, isn't it? Or benzoyl peroxide also we can say. Means the mechanism I'm showing it for benzoyl peroxide. Okay, so here they given tertiary butyl peroxide. Fine. So here I'll be showing it for benzoyl peroxide. You can relate it with that. So when I take benzoyl peroxide, this is C6H5, C double bond O, C double bond O, C6H5. So what is this? This is benzoyl peroxide. Now the same thing you will be making it with tertiary butyl peroxide. Okay, peroxide group is the same, but this will change. The tertiary group will be there. Done. So in the first case, there is formation of cleavage of bond. It will break exactly here. This is, you have this mechanism for your grade 12. So one part and one part, both are similar. So 2C6H5, C double bond O, see here. Done. Now further, there is a cleavage of the bond here and you get 2C6H5. What is the name of this? This is called phenyl free radical. Phenyl free radical. Okay, done. So here what happened? we are getting benzoyl free radical, okay, right? But there you'll get tertiary butyl free radical. Simple. Now the next step, what happens now? This free radical, whatever is there, it's going to attack one ethene, okay, that is what they said, isn't it? Ethene molecule. So what happens? This free radical, the bond here breaks up, and this free radical goes and attacks this carbon. Now what do I get? I get C6H5, CH3, CH3. This is phenyl free radical. There I will be writing tertiary butyl free radical. Now this is a free radical, you can write. Now in the propagation step, what happens? This C6H5, CH2, okay, this is CH2, CH3, what do you write? CH2, this also should be CH2, okay, I'm sorry for that. Sure, this is there, isn't it? This free radical is going to again combine with one more molecule of ethene. First molecule here, second molecule here. Then what happens further? This is shifted to this, and this bond is going to. So what do I get? I get C6H5, done. Now the chain starts increasing like this. So what do? I write CH2 here. Now I'll be taking this CH2, then I'll be taking this CH2, then I'll be taking this CH2, then I'll be ending it. This goes on like this, this chain goes on like that, and finally what happened? Here I get CH, means like the thing goes on and the free radical is present at the end. The chain goes on and on. For terminating, we are going to take this thing, the same thing for termination. I'll be taking C6H5. This whole chain is there, and the CH2, this is with N, means it continues with CH2. Now what happens? This combines with, because this whole chain is this one, this combines with one more C6H5, CH2, it goes on like this. Fine. So means the chain finally it has to terminate, so it's going to combine with one more molecule of this, a larger molecule, right? So finally I'm going to terminate the chain with CH5, done. CH2, what did I do? C6H5, CH2, N, done, right? And means this chain again continues, and finally I'm writing the same thing, and finally it will fix up with CHN. This will be N. So here also C6H5, here also C6H5, I get polyethene, done. So this is your free radical free radical mechanism or free radical mechanism of benzoyl peroxide. I have shown it for benzoyl peroxide. You can practice it for tertiary butyl peroxide. So let's come back and do one more question. That is the next question of your. Welcome back, students. Let's come back and do the 9th question. We have seen 7th question. Now 8th question also done. 9th. What did they ask me? Basically they said write the mechanism of acid dehydration of ethanol to form ethane. Right. So two things are given. I have to show the mechanism of dehydration. Which one? I have to take ethanol, then finally prepare ethane. Done? Yes. So ethane, no, this should be ethene. I'm sorry. Done. So whenever we are doing the mechanism, first important thing, the examiner will be very careful. He'll be observing step 1, step 2 like that. So first write step 1. Done. So for step 1, you will write what? What is step 1? It is basically formation of protonated alcohol. Protonated alcohol. This is your first step. So here for writing the reaction, you will be getting half mark. I'll be writing. So the next step, step 2. What is step 2? Here it is formation of carbocation. This is 1 mark. Remember, most important. After that, let me turn the page. It is step 3, which is formation of ethene by elimination of proton. Formation of ethene by elimination of proton. Done. For this you will be getting half mark. Okay, let's start. So whenever I take, because basically you have 5 different types of mechanism which are compulsory in grade 12. Done. This is one among them. So whenever I have said protonation of alcohol, formation of protonated alcohol, start this mechanism with ethanol. Ethanol is 2 carbon, 1, 2. This is O and H. So fill in hydrogens around carbon, hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. Done. So count the number of this one 1, 2, 3, 4, 5, 6, 7, 8. Then this is what? Ethanol. Let us write ethanol. Done. Be careful, you have to name everything. Now we said formation of protonated alcohol means what? You need to add a proton to this. Okay, so the reaction here is very fast. First protonated alcohol, then formation of carbocation. Now this is H plus. This H plus attacks the oxygen atom which has a pair of electrons. Then what do I get? I am going to copy the same thing. Hydrogen, carbon with 3 hydrogens. Fourth is carbon, again hydrogen, hydrogen. Now I said this H plus attacks oxygen. So on the top of oxygen you have hydrogen here, and this has lost a pair of electrons, so this becomes positive and H. So what is the name of this? This is called protonated ethanol. Means proton is added to that. So protonated ethanol. Okay, or ethyl oxonium ion. It is also called ethyl oxonium ion. Okay, done. Right. Next step. Now first step is over. Then second step, formation of carbocation. We are going to take the same here. So we added hydrogen. Now sorry, H plus. And this, I'm going to take the same thing. Then H, then hydrogen, then oxygen, then hydrogen plus and H. Now this reaction is very slow. So what will happen? There is a cleavage of the bond because I have to form a carbocation. There is a cleavage of this bond. That comes out as water molecules, H2O. Water is out. What are we left with? Now we are going to form the carbocation. See, hydrogen, this is carbon, this is hydrogen, this is hydrogen, this is also hydrogen, this is hydrogen, and this is plus. Okay, now we have got a carbocation, that is ethyl carbocation. Let us write that. It is called ethyl carbocation. This is done, students? Yes. Now step 3 I have to follow. So when I have to come back to step 3, hope this is clear, students. Formation of ethene. Any doubt? Please let me know in the comment section, because mechanisms are compulsory in your board examination. You have to be very clear while practicing. Then let's come back to third step. So in third step, it is formation of ethene by elimination of proton. Now let me take the carbocation. Carbon, carbon, hydrogen, 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 and plus. Right. Now what will happen here? Formation of ethene by elimination of proton. I'll be eliminating a proton from this. Okay, so this, because I have to prepare my this one, what ethene, isn't it? So proton, one proton, this will be eliminated, and what do I get? C double bond. The bond will be shifted here. C double bond C, H, H. This is one hydrogen, this is one hydrogen, and H plus. So finally I've got ethene. So this is a mechanism. So simple, students. So careful. One important thing you have to remember, whenever you're doing mechanism, step by step should be written. Let us come back and do the 10th question now. What do they give us? It's a chemical kinetics question. Let's read. Give a certain for a certain reaction, variation in concentration, that is variation in concentration versus time. Plot is given below. Okay, done. So they've given me a negative slope. Predict the order of the reaction. Done. What does the slope of the line and intercept indicate? Done. What is the unit of rate constant? Okay, so basically, first important thing, this is a 2 marks question. What does what do they want you to do? They want you to write the order of the reaction. They want you to write what does the slope indicate. After that, unit. For knowing the slope, first of all, you should know what is the formula, right? So simple. I'll make you understanding. This is a graph. So for such questions, first, whenever you're learning, try to make okay, I'll leave this place for the answer. I'll explain you how to remember. Okay, I don't have place. Let me take a page for this, an A4 paper for explaining this, right? So remember the whole chemical kinetics I'm summarizing here. So first of all, we have 0th order reaction. Okay, correct. Then we have first order reaction, correct. Then we have second order reaction. So basically in the exam, if they ask you what criteria they're going to ask you, let's see. So here they're going to ask you first differential rate law. Remember that. So first important thing you should remember is differential rate law. So for the zero order reaction, it is denoted like this. After deriving the formula, you can directly remember, because this will be useful for your 1 mark question. By T is equal to K. For the first order reaction, it is equal to minus delta A dash T is equal to K A. Right. Now, when it comes to second order, it is minus by T, which is equal to K A square. Done. Now, this is differential rate law. Next thing which you should remember for your 1 mark question is integrated. Let me make one line here. Integrated rate law. Next one which you should remember. Next one is A is equal to A naught minus KT. Here integrated rate equation which we've already derived in what? A naught E raised to power minus KT. So if I write in terms of ln A, this becomes ln A naught minus KT. So this one 1 by A is equal to 1 by A naught plus KT. So remember this. Now, when I have to write or represent in the form of a graph, so straight line plot. Why are we applying? We are doing this. We are doing this to get the constant. So to determine constant. So remember this of this chemical kinetics. This will be over. Determine constant. So what do? Draw graph. Concentration versus time. Here, ln concentration versus time. Here 1 by concentration, because it is 1 by, isn't it? 1 by concentration and time. So in the zero order reaction, you get a graph like this, straight line with negative slope. Slope is negative. In this course also, we'll be getting graph and the slope will be negative. In this case, you get like this. It's a positive slope, isn't it? Slope is equal to positive. Okay, let us turn the page. Now what are we going to write? We are going to write important thing, half-life period for all these. Half-life. So for the zero order reaction, let me again draw the line. Okay, lines are not straight, students. That's not a problem. For us, information is important. Zero order, first order, second order. So for this zero order, half-life is equal to A naught by 2K. For the first order, T half value is equal to 0.693 by K. For this one, second order, T half is equal to 1 by K. Yes, it is K. This one T naught, isn't it? Your concentration. A naught. Done. So when I have to write the units for this, right? So they've asked me units also. So units of K, that is your rate constant. So what are the rate constant units? Let's see here. Concentration means molarity by S. In the second one, it is 1 by S. In the third one, M inverse, second inverse. So this is the data which you have. So you always remember these four. Very important thing for your exam. This one, these four. This is enough. If you remember this, I can write the answer. Now what do we ask? What is the predict the order of the reaction? So this graph looks like this, isn't it? So when this graph looks like this, what should I write? The order of the reaction. First one is zero order reaction. Okay, next zero order reaction. Now what do they ask? What does the slope of the line and the intercept indicate? Right, slope of the line and the intercept indicates. What is slope of the line? It is minus K. Correct. Now what is the intercept? For knowing the intercept, see here, this is the intercept, isn't it? Correct. Why? It's good. This is because y is equal to, right, just see here, y is equal to intercept, but this is mx plus c is nothing but a naught. So let us write that. So here you will write slope represents minus K. And what does the intercept represent? It is nothing but, according to the formula, A naught or R naught. concentration. Now what did they ask? What is the third one? They said what are the units? See here, I have explained you the units also for 0 order. Molarity by second, right? What is molarity? Mole per liter inverse. So write that unit, mole liter inverse second inverse. That's it. Over invented. So that's a question. Let's come back and see simple. So remember, for chemical kinetics, remember 1, 2, 3, 4 and 5. That's enough for the whole chapter. Now let me come back and do the 11th question. What did they ask? Draw the molecular structures of the following noble gas species which is isostructural with BrO3. So they're asking us to draw a structure which has similar structure like BrO3. So they said, they've given a clue here, noble gas elements. They said noble gas elements, nothing but your Xe or xenon, or helium, neon, argon, krypton, xenon. So xenon, and xenon basically forms XeO3 products. So XeO3 is the one which is similar to this BrO3 minus. Let us draw the structure. So BrO3, nothing to draw the structure, XeO3 only. Xe, okay, double bond O, double bond O, double bond O with lone pair of electrons. Done. Next, they've asked me dibasic of phosphorus. So basically phosphorus forms H3PO3, H3PO5, like that, you know, it forms different compounds. So they've asked me oxoacid of phosphorus. Dibasic oxoacid. Dibasic means what? OH group should be, 2 OH group should be there. So let us write, there's nothing but phosphorus in the center, oxygen here, hydrogen here, OH here, OH here. So what is this? It is nothing but H3PO3. See here, this is one hydroxide, one hydroxide, so 2 are there. That's why it is dibasic in nature. Right. Now 12th. So when I take the 12th question, what do they ask me? On the basis of the SEP values, okay, stated for acid solutions, predict whether Ti+4 species may be used to oxidize Fe+2 to Fe+3.